All right, students, this is chapter 12, and these first couple of lessons we're dealing with just surface area. And if you remember, surface area is the area of all of the different faces of a particular polyhedron. Now, this includes lessons 12.2 and 12.3. It also, on the very bottom of the second page, is spheres. But spheres is 12.6, and we are going to be saving this part until we get to 12.6. So we're going to do all the different polyhedrons except, well, a sphere is not a polyhedron, but we're going to do the surface area of these different figures except for spheres. All right, now, to be careful. Be very careful with these formulas. Everybody thinks, oh, it's nothing but formulas. It's easy peasy. I can do this. All right, guys, you got to know what these formulas mean. Okay. In here, I've got the formulas for a prism and a cylinder, and we've already gone over what a prism and a cylinder are. Now, there's two things to look for: lateral surface area and total surface area. Lateral has to do with the part that goes around. It's between the two bases, and in the cylinder, this is the lateral right here. It's between the bases. If we look for total, then it's the lateral plus the bases. And in this case, it would be the lateral plus the two bases, the two circular bases. All right, so if you look, this perimeter times height is your lateral, and then you take that perimeter times height and add it to the area of two bases, which in this case are your two triangles. Here you've got the lateral surface area is 2 pi r(h), and that's this part here. And then you take that and add it to 2 pi r squared. Your pi r squared is the area of the circles, and there's two of them because remember there's one on this other side as well. Now, this is the very same thing as this formula, except they took out the greatest common factor. Each of these has a 2 pi r, so it was taken out and you were left with h plus r. So this is the factored form. And if you have to do total surface area only, this one is a little bit easier. But if you had to do lateral and total, then you would probably go this route. So it's just personal preference, actually. Okay, now anytime you see the capital P or C, that has to do with the perimeter of the base of the prism. Okay, so in this case, capital P would be the perimeter of this triangle, or C, the circumference of this circle. The capital B, this is muy importante. It's the area of the base of the figure. Okay, and the bases are the two parallel and congruent faces. Now, this base in this figure is a triangle. So this capital B, we would have to have the formula for the area of a triangle. In this figure, the base is a circle. So if we had a capital B in this one, we would have to have B times, or B being the area of the circle. So you've got to be very careful when looking at these. Also, I want to show you a formula chart real quick. We just got finished with chapter 11, and if you look at the area of these different figures that we did, there is a little b. And in a triangle, for the area of a triangle, the little b is base times height, but this base is nothing more than a length right here, and the height is how tall it is. Okay, so that little b has one meaning for base, but this capital B that you see down here has a totally different meaning. Capital B is the area of whatever that figure is. Okay, so in looking at this, let's go ahead and get started. I'll zoom back in here. We're going to just focus on this triangular prism. Okay, we have a regular triangular prism, and we're going to start out by finding the perimeter of the base. That's a capital P. So if you saw a capital P, this is what you would do. It's regular, so all sides are 14. There's 3 sides, so 14 times 3, and that gives you a perimeter of 42 meters. Okay, then the surface area lateral, we're looking at this rectangular portion that goes around here. All right, to find the surface area lateral, we need perimeter times the height. Perimeter times the height. Well, our perimeter we just found was 42. Now the height, this is where you need to be careful. The height is always the distance between the bases. Exclamation mark. This is huge. So the height of this prism is right here. This is the height. It's the distance between the two bases. So 42 times 10, and of course that gives you 420. Since we're talking about area, we want meters squared. So now, find the area of the base of the figure. That's the capital B. That would be this part. Well, our capital B is a triangle. Okay, we have a triangle. So this B would be the formula base times height divided by 2. And that would give us the area of this triangle. Okay, we got to go way back to chapter 7 to do this. We draw our altitude, okay, splitting our equilateral triangle in half, cutting this 60-degree angle into a 30-degree angle, right angle here, and cutting this side in half so that this portion is only 7. Okay, now if this is 7 and it's across from the 30-degree angle, it's our short leg. So the altitude here would be our long leg, making it 7 radical 3. Okay, so now we've got our base, which is 14, and our height, which is 7 radical 3. Now keep in mind, I'm talking about a different height. I'm working with the base of my figure, and the figure is a triangle, and I want the height of the triangle, which is different from this height, which is the height of my prism. All right, this can get very tricky, and you've really got to pay attention to what you're doing. So I've got the area of my base is 14 times 7 square roots of 3 divided by 2. All right, and this would divide out, so to give me 7, and 7 times 7 is 49 square roots of 3. So I can just leave it in simplified radical form, and I don't need to use a stinking calculator. That's what I love about exact answers. Now, find the surface area total. Well, I need perimeter, height, and the area of 2 of my bases. Okay? So my perimeter, I go back here, my perimeter was 42. And my height was 10. Okay? And I'm going to add to that the area of 2 of my bases. Now, this whole thing can be put in the calculator easy peasy, or we can just go 420 plus, and 49 times 2, oh, what is that? 98 radical 3. And then you would definitely need to put that in the calculator to get a decimal answer if we're going to combine those together. And you should get something like 589.7 meters squared. And that would be my total surface area. All right, now then, let's take a look at a cylinder. All right, our cylinder, we are going to start off with finding the circumference, the capital C. Okay, well, our circumference of the circle would be 2 pi r, and so that would be 2 pi 4, or 8 pi, or if you multiply that out, 25.1 inches. Okay, surface area lateral. So let's look at this formula right here. 2 pi RH. Okay, we have 2 pi RH. h. 2 pi 4 12. This is your height right there because that is the distance between the two bases. All right, so 4 times 12 is 48, times 2 is 96, times pi, that gives us 301.6 inches squared. Now, find the area of the base. Well, capital B in this situation would be a circle. So to find the area of a circle, 2 pi, I'm sorry, I did a boo-boo. Oh, I hate it when I do that. It's pi r squared. That's the area of a circle. So it's pi 4 squared, which is 16 pi, or 50.3 inches squared. Find the surface area total. Okay, well, we can use this formula if we want to, but we've already found this 2 pi rh, and we found pi r squared. We just have to double it. So we've got 2 pi rh, which is this number, 301.6, plus 2 of our bases, 250.3. We multiply that out and add it to 301.6. We get about 402.2 inches squared. Okay. I'm not putting this in my calculator for y'all just because it is it's standard operations and there's nothing tricky in these. And I'm just kind of trying to save time in the length of these notes. Okay, now we've got 2 more shapes to go over. This one is pyramids and cones, so we got the little pointy ends. All right, same thing right here. Capital P is perimeter, C is circumference. Capital B is the area of the base. H is the height. But look right here. It's the perpendicular length of the pyramid or cone. So in this situation, I want you to draw a picture of a cone. Okay. Okay. This right here, perpendicular distance, so from the very tip of that cone perpendicular to the base so that it makes a right angle, this is your height. Now, this cursive L represents the slant height for pyramids and cones, which is totally different. This is your slant height because it is slanted and it goes from the bottom to the top. So be very careful between the difference of those. It's very easy to get those confused, but this is something that's very important that you need to be aware of in your formulas. Okay, so in a pyramid, for the lateral portion, okay, if I were to draw, I'll draw a little pyramid right here. Okay, this is the lateral part. It's the triangles. And so I need my perimeter times my slant height divided by 2. And in reality, what this perimeter is, that's the length of the base of the triangle, and my slant height is actually the height of the face of that triangle. So basically, it's the area of this triangle times 4 if the base is a square. So that's something to think about. This is really the formula for the area of a triangle. Here, this is the same thing. This is your lateral portion plus the area of the base. So that base could be a square, rectangle, triangle, pentagon, octagon. It can be any of those shapes. So that capital B is you need to use whatever formula attends to that shape. And then your cone, this one's a little funky. All right, your lateral surface area is this part right here, and your formula is pi RL. So it's pi times the radius times the slant height. And then total surface area is your lateral plus pi r squared. That's your circle. That's your base of your figure. Now what they did here is they looked at these and they took out the common factor of pi r and then put the leftovers in parentheses. This is the same thing. In fact, it just factored out as this formula here. So let's practice those problems. Flip it over, and we're going to start off with the pyramid. All right, and in this picture, we've got a square pyramid, so the base is a square. So if we're going to find the perimeter of the base, each side is 15, and there's 4 sides, so that's 60 centimeters that we're looking at. Find the slant height. Well, guess what? We don't have to find it. It's already written there for us. That's this height right here. And then if you notice, if this was just a flat triangle, if we just flatten this out and looked at this triangle, that slant height is the height of this triangle, of that face. Find the surface area, lateral. Well, our formula is perimeter times slant height divided by 2. Okay, so our perimeter is 60. Our slant height is 9. Divide that by 2. That would be 30 times 9, or 270 centimeters squared, because we're talking about area. Now then, find the area of the base. All right, in this particular figure, we have a square. So 15 squared would give us the area, or 225 centimeters squared. Find the surface area total. Okay, total surface area is our lateral plus our base. So our lateral surface area is 270 plus our base, which is 225, which gives us a total of 495 centimeters squared. Keep in mind, I'm just picking the formula apart, doing it one step at a time, and it takes a little while, but you don't necessarily have to do your formula this way or practice it this way when you're doing the homework assignments. But I just want you to see how it comes together step by step. Okay, the very last one is a cone. Okay, and it says to round to the nearest tenth and use 3.14 for pi.
Harrelson and Maria Velasco.
Time out.
That's Emma Harrelson and Maria Velasco. You both have an item in the front office. That's Emma Harrelson and Maria Velasco. Please come to the front office straight away. Thank you.
Okay, I prefer the pi button. For tax, we usually use 3.14. And to be honest with you, just be consistent in whatever you use, and I will be fine with that. So 2 pi r is circumference, so we've got 2 pi 4, which is 8 pi, or 25.1 meters. The slant height. This is our slant height right here, so it's 10 meters. Find the surface area, lateral. Okay, so we want to find the surface area of this part of the cone, and that formula is pi, wrong place, pi r l, where r is 4 and the slant height is 10. And so that gives you 40 pi, and if you multiply that out, you should get about 125.7 meters squared. Now, find the area of the base. Well, the base is a circle, pi r squared, so pi 4 squared, 16 pi, or 50.3 meters squared. Now, to find your total surface area, we're going to add lateral to the base. So we're going to take 125.7 and add it to 50.3 and get 176 meters squared. All right, now those are the 4 figures we're focusing on for surface area. This circles or spheres we'll do at a later time. Just keep in mind, within these formulas, what we can do is give you the actual height, and you have to find slant height. And that goes back to Pythagorean theorem or possible trig ratios. Same thing over here. If they give you the actual height of the pyramid, which goes from that tip perpendicular down, you would draw a line here, and this would be your right triangle, and this is your hypotenuse. So there's a lot of different tricks and things that can be thrown in here to make these a little bit more challenging. That's it, guys.